In previous lecture, we have started 11th Physics second chapter Mathematical Methods and studied the definitions of scalar, vector, zero vector, resultant vector, negative vector, equal vector, positive vector and unit vector. Today, we are going to see the vector operations. Vector operations. In vector operation, first we discuss about the multiplication of vector. Multiplication of vector by scalar. Let us consider vector p bar. Multiplying a vector p bar by a scalar quantity, this is a vector, and multiply by the scalar s, we get the quantity vector q bar. After multiplication of this vector p bar with this scalar s bar, we get another vector q bar in this way. In this, here, what is this? Q will be vector whose direction, Q is the vector whose direction is same as that of p bar, and magnitude of this vector is s times the magnitude of vector p bar. Okay, in this way we can make the multiplication of the vector by a scalar. In next step, we have to consider what is composition of vector. Composition of vectors. The process of finding the resultant of two or more vectors is called as the composition of vector. Process of finding resultant of two or more vectors is called as the composition of vector. Okay, now we are going to second vector operation, and that is the addition and subtraction. This is first vector operation and this is second vector operation, addition and subtraction. Addition and subtraction of vectors. Addition and subtraction of vectors. When we think about addition or subtraction of two vectors, not only two vectors, two and more vectors, the vectors must be of same type and describing same physical quantity. This is possible only when vectors are of same type and describing same physical quantity describing same physical quantity. This is a requirement of the addition and subtraction of vector. The addition and subtraction of two or more vectors of same type describing same physical quantity gives rise to a single vector. This is the resultant. Single vector. Such that vector कसा असेल? Such that effect of this single vector is same as the net effect of the vectors which has been added. or subtracted. Addition and subtraction of two or more vectors of same type describing the same physical quantity gives rise to single vector such that effect of this single vector is same as that of net effect of the vectors which has been added or subtracted. Okay, this is the addition and subtraction of vector. This is the first condition, that is only vector of same type describing same physical quantity can be added. Example, force. F1 and F2 are two force vectors can be added to give a resultant force F bar. Then we can write F bar is equal to F1 bar plus F2 bar. Okay. But this force vector cannot be added to velocity vector because it needs vectors of same type and describing same physical quantity. Okay. Now, in addition, when we add two or more vectors, at that time it is easy to find out the addition of vectors having same or opposite direction. Direction may be same or opposite, and also magnitude is different, because when we want to add the vectors, they may have same magnitude, different magnitude, same direction, opposite direction. So in first case we think that the individual vectors are parallel to each other. Individual vectors are parallel to each other. Parallel to each other. Parallel to each other, having same direction. Same direction. Direction कशी असणार आहे दोन्हीची? सेम असणार आहे. Then their resultant is addition of two individual magnitudes. Then their resultant, मग आता याचा resultant कसा मिळणार आहे? Resultant is the addition. कोणाचे addition असणार आहे? Addition of these two individual vectors which are parallel to each other. How it is given? Suppose AB bar and BC bar are two vectors. They can be added to give a single vector AC bar. How it can write? AC bar is equal to AB bar plus magnitude of A bar. Magnitude is always resultant has the addition of magnitude of two individual vectors BC. Okay, and it has a direction. We think about this as magnitude. What about direction? Because we have going to vector operation. Direction of resultant is that of individual vectors, because this is AB bar, this is BC bar, this is second vector. If it has a magnitude 5 cm, this has magnitude 7 cm, then the resultant is the having magnitude is addition of individual vector, that is 12 cm AC. Okay, and direction of the resultant is same as the individual vector. This is in case of individual vectors if they are parallel to each other. In second case, if they are anti-parallel to each other, anti-parallel or opposite. opposite to each other, anti-parallel or opposite to each other. मात्र ते जर अँटी-पॅरलल किंवा अपोजिट असतील तर काय होणार आहे, द मॅग्निट्यूड ऑफ रिझल्टंट. आता फर्स्ट आपण थिंक अबाउट द मॅग्निट्यूड ऑफ रिझल्टंट इज डिफरन्स. मॅग्निट्यूड इज, इथे ॲडिशन होतं, इथे काय असणार आहे, डिफरन्स. मॅग्निट्यूड इज डिफरन्स of the individual magnitude, okay. And what about direction? And the direction is direction of the large vector, direction of the large vector. Now again we have to consider same example, that is AB bar and BC bar are two vectors, okay, and AC bar is their resultant. Now it can be written as AC bar is equal to magnitude of AB bar minus magnitude of BC bar. Magnitude of this quantity, difference between these two, difference of the individual magnitudes. Difference of individual magnitude is the magnitude of the resultant. And then direction. Suppose this is vector AB having magnitude 30 Newton, and this is the second vector BC. AB can be subtracted, BC can be subtracted from BC, that is the which having magnitude 5 Newton. Then the resultant has direction of larger vector, that is the AC. That is the 8 Newton. Difference, magnitude of resultant is the difference of individual, that is 13 minus 5 is 8 Newton, and the direction is of larger vector. This is the addition of the two individual vectors which are parallel and anti-parallel to each other. Now we are going to see the most important part, that is the triangle of vector addition. Triangle law of vector addition. First law, we have to learn two laws. This is the first. What is statement of this law? If two vectors describing the same physical quantity, if two vectors describing the same physical quantity are represented in magnitude and direction by two sides of triangle taken in order, then their resultant is represented in magnitude and direction by third side of triangle drawn in opposite sense, that is starting from the starting point of first vector to the end point of the second vector. This is the statement, but we can understand this by diagram. Let us consider vector A bar and B bar. These are two vectors. What is the first sentence of the statement of the law? If two vectors describing the same physical quantity, these are describing same physical quantity represented in magnitude and direction by adjacent sides of triangle. This is vector, suppose PQ. This is vector A bar. RS, vector B bar. By applying triangle of vector addition, as we think about the first sentence, that is if two vectors are describing the same physical quantity are represented in magnitude and direction by two sides of triangle. Two sides of triangle. This is vector A bar. This is vector B bar. This is P, Q, R, S. Two vectors represented in magnitude and direction by two sides of triangle, and condition is they are taken in order, one after other. End point of the second vector is the starting. End point of first vector is the starting point of the second vector. That is, they are taken in order. Then their resultant is represented by third side of triangle. Third side of triangle drawn in opposite sense. Drawn in opposite sense. Opposite sense. Why it is opposite sense? Because these are taken in order, but this resultant has opposite direction that of the order. Okay, hence they are in opposite sense. In simple word, magnitude of the resultant, magnitude and direction by the third side of triangle असं आपण म्हणतो. तिसरी बाजू जी आहे ती that represents the addition of these two vectors. तो कसा ड्रॉ केला जातो? It can be drawn from starting point of first vector to the end point of the second vector. This is the triangle law of vector addition. That is, the C bar is the resultant, can be represented by this A bar plus B bar. Okay, this is triangle law of vector addition. What is use of the triangle law? Uses of triangle law. Uses of triangle law. First, vector addition is commutative. Vector addition is commutative. Vector addition is commutative. For this, again we have to consider two vectors P bar and Q bar. As we think that which vector addition is commutative, that means P bar plus Q bar is equal to Q bar plus P bar. पहिला वेक्टर हा दुसऱ्यामध्ये ॲड केल्यानंतर जो रिझल्टंट मिळेल तोच रिझल्टंट आपल्याला केव्हा मिळणार आहे? दुसरा हा पहिल्यामध्ये ॲड केल्यानंतर. दॅट इज द वेक्टर ॲडिशन ओबेज द कम्युटेटिव्ह लॉ. ओके, लेट्स सी बाय द diagram. This is the OA represents vector P bar. AB represents vector Q bar. Then according to triangle law of vector addition, this is the resultant R bar. This is P bar plus Q bar is equal to R bar. Okay, this is one side of the equation. Now this Q bar, this is Q bar plus P bar again, and this vector gives the resultant according to triangle law. This is the second side. Both has the same resultant, hence vector addition obeys the commutative law, that is P bar plus Q bar. In triangle OAB, what is this? P bar plus Q bar is equal to R bar is equal to OB bar. In triangle OCB, Q bar plus P bar is equal to R bar is equal to OP bar. Both are same, hence P bar plus Q bar is equal to Q bar plus P bar. Okay, that means this vector addition obeys the commutative law. Second law, associative. Vector addition is associative. Vector addition is associative. Vector addition is associative. Associative. Vector addition is associative. For that we have to consider three vectors, a bar, b bar and c bar. These are the three vectors of same type. Okay, then according to this law, a bar plus b bar plus c bar is equal to a bar plus b bar plus c bar. Okay, this is associative law. Now we are going to prove this law. For that we have to consider two vectors. This is starting from this point O, vector a bar, again O P, this is first vector. Now second vector b bar, that is P Q. Then the resultant is represented by this vector r bar. Okay, it is equal to a plus b bar, a bar plus b bar. Now this can be added to next vector r. This a plus b can be added to next vector c bar. Then we get this resultant of this all three. This is a plus b, where we say this is resultant. Okay. Now how we get this resultant? This is a plus b plus c bar. Okay, in this way we get the resultant. Now again, this is the first part. This first part. How we get in first part we get the resultant a plus b plus c bar. This is the first part. In second part, we have to think about this side. Okay. Now this a bar, we have to add this a bar with b plus c. B plus c. How we get the resultant of these two? Resultant of these two is the b plus c. This is the resultant of these two vectors. Addition of these two vectors is b plus c. Now we have to get this resultant. This is the output of this b plus c. Now we have to add this with vector a, because vector a plus b plus c. Then we get the resultant r bar is equal to a plus b plus c. R bar is equal to a bar plus b bar plus c bar. Okay, we get the same resultant. That means this vector addition obeys the associative law. Okay, this is the vector addition. Now we think about some examples.